All right, so we remember that our pattern for the 30, 60, 90 triangle, 30 is across from the shortest side, it's x. The hypotenuse is across from the 90-degree angle, it's 2x. And then the longer side is x times the square root of 3. Okay, the problem that we see here, we're given 9, which is the longer side of the triangle. Well, it's kind of hard to work backwards if it's not in the format of a number times the square root of 3. All right, so what we have to do here gets a little bit tricky. We take this and we set it equal to its proportion here. Now, there's already x's and y's in the problem and all that, so I'm instead of x's going to use a for these. All right, so I'm going to call this 9 equals, and instead of x times the square root of 3, I'm just going to call it a times the square root of 3. Now I need to solve for a. Okay, so let's figure out what this is. So divide both sides by the square root of 3. All right, so 9 divided by the square root of 3 equals a. All right, well, we know that we're not allowed to leave square roots in the denominator, so I'm going to multiply the top by square root of 3 and the bottom by the square root of 3. So this becomes 9 times the square root of 3 over 3 equals a. And one last simplification, 9 over 3, we know, is 3. So 3 times the square root of 3 equals a. So here, okay, I have gone through the process of solving for what this x is, or this variable in front of the square root of 3. Okay, so that is the same as the shortest side. So I have to refer back to my problem here and see that the shortest side is labeled y. So technically in this problem, y equals 3 times the square root of 3. Right. Now it's a little bit easier to find x because the relationship of the shortest side to the hypotenuse is just double. So I just have to multiply this whole thing by 2, which basically just means multiplying that number out in front by 2. So this is 6 times the square root of 3. So it's a little bit of a process to get through to do this kind of a problem. Again, you can use Pythagorean theorem. This problem, you really couldn't do that quite yet because we're missing 2 of the sides. We'll learn another method in the next chapter that would help us with that also. Okay, but if you can remember this property, it can help you get to those answers. All right, here we go again with the 45, 45, 90. Okay, here we know x, and x times the square root of 2, okay, is our property. Okay, here we're given 3 for the hypotenuse, but it's not 3 times the square root of 2 or something that would make this easy. So what we're going to have to do is take this 3, set it equal to x times the square root of 2, and solve for x. Okay, so 3 equals x times the square root of 2. To get rid of that square root of 2, I have to divide both sides by the square root of 2. Okay, so 3 over the square root of 2 equals x. And again, I need to rationalize my denominator. So square root of 2 times, or over square root of 2. So I'm going to multiply top and bottom. Okay, so this becomes 3 times the square root of 2 over 2 is x. Okay, and x is what we used for the shorter side here, so that is the final answer for this. Okay, so my two congruent sides here would be 3 square root of 2 over 2. So it takes a little bit more work if you're given the hypotenuse or the longer side, depending on the property here. But you can work backwards to find those side lengths. Okay, you have an assignment to work on that is all special right triangles, so please try applying these rules to that worksheet.